Question 3 says the volume occupied by a sample of gas is 480 milliliters. When the pressure is 115 kilopascals, what pressure must be applied to the gas to make its volume become 650 milliliters? So I know that 480 milliliters is a unit of volume. I know that 115 kilopascals is a unit of pressure. The question literally says what pressure, so I know I'm going to be looking for pressure. And then I have 650 milliliters. This is a unit of volume. I want to now figure out who's my initial and who's my final. So the question tells me that I have a sample of gas that's at 480 milliliters and its pressure is 115 kilopascals. That means those two need to stay together. What pressure must be applied to now turn this 480 milliliters to now 650 milliliters? So because it says I need to become this volume, this is going to now be a sign that this is my after, because this is what I'm trying to become. So I started with 480 milliliters at 115 kilopascals. I want it to be 650 milliliters. I'm trying to figure out what pressure is that I need. So now I know who's my V1P1 and who's my P2V2. The only formula that has both volume and pressure is Boyle's law. So I can go ahead and answer that part of the question. Remember, Boyle's law is V1P1 equals V2P2. And I want to solve for P2, so I'm going to just divide by V2 on both sides. And that now helps me get rid of the V2. And I'm left with my formula, which is P2 equals V1P1 over V2. Now I can just plug in everything from my question. My V1 from the question was 480 milliliters. My other volume was also in milliliters, so I don't need to worry about doing any conversions here. I can go straight to P1. My P1 is 115 kilopascals. I don't have any other unit of pressure in my problem, and it's not asking me for a different unit, so I can go ahead and finish up that P1. I can now divide by my V2, which is 650 milliliters. Now I just go to my calculator and I let my calculator do this part of the work, where I can now just multiply 480 by 115, and hopefully you get 55,200. And then when you divide that by 650, you're going to get a pretty long decimal value. So if you're trying this out with your calculator, hopefully your calculator is staring back at you with the same exact number. Now I need to deal with sig figs. So if I go back to my question, I want my data to always be what was really happening and not what it could be or what I want it to be. So my volume is 480 milliliters and my pressure is 115 kilopascals. That means that 480, that's a trailing zero, no decimal. This is 2 sig figs. My pressure is 115 kilopascals. That's 3 sig figs. I really shouldn't use 650 milliliters as part of my sig figs because that's not the reality of what I'm sitting and looking at. That's just a number of what I want it to be. If I were to accidentally use this as part of my sig figs, it's still 2 sig figs. So I want to make this really clear for you. When you're going to take a quiz or a test, I'm not going to set up any sig fig values where your lowest sig fig is actually a data you should not have been using. So even if you did say, I'm going to look at 480, 115, and 650, and 480 and 650 both have 2 sig figs, you would have still answered this correctly. It's not going to affect you when you take the quiz or the test. I'm not going to set up the questions where they're tricky. The only thing that you never want to use for sig figs would be temperature in Celsius or temperature in general. Boyle's law doesn't use temperature, so you're all set. So what you're going to do now is you're going to give me a final sig fig answer. And if you can make sure that you've boxed it or circled it or highlighted it, that's what I need to see on your page for number 3.